continue solving systems of equations, and now we're going to solve by graphing. Okay, so how to solve by graphing? First, make sure both of your equations are in slope-intercept form, which is y equals mx plus b. And the reason being that we could graph it in standard form, we could graph it in point-slope form, but slope-intercept form tends to give us more points. It's easy just to keep counting using your slope, right? And the more points you have by putting on your graph, the less guessing you have to do because you can see exactly where your lines cross. All right, step 2, graph both your equations on the same coordinate plane. Step 3, find where they intersect. And then that is your solution, which you can always check by plugging back into your equations. So for our first example, neither one of these are in slope-intercept form, so that's what we're going to do first. So I'm going to start by subtracting x for the first equation. So we get negative y equals negative x minus 1. Then divide everything by negative 1. So y equals x plus 1. Second equation, again, subtract the x, so 2y equals negative x plus 5, and divide everything by 2. So y equals negative 1/2 x plus 5 halves. So just because I don't have any fractions in the blue equation, I'm going to graph that one first. I'm going to go up to positive 1, and then go up 1, right 1. All right, and we're going to go a couple times in both directions with the first graph, just to give yourself plenty of options for seeing where the intersection is. And that should be good enough. Connect it. Ooh, try to connect it. And make our line. Then we'll come back with the row, which isn't the prettiest of numbers, but it still works. 5 halves is 2.5. That's right here. And then I'm going to go down 1, right 2. And once I do that, I can see exactly where they're going to cross. And I can see that my answer is 1, 2. Right, and for our second example, same thing, got to get them in slope-intercept form. So for the first one, I'm going to subtract 3x from both sides. So we get 6y equals negative 3x plus 15. Divide everything by 6. So y equals, and I can simplify that to negative 1/2 x, and 15 over 6 becomes 5 halves. So I have the same equation we just graphed. And then for this one, I'm going to add 2x. So 3y equals 2x minus 3, and divide everything by 3. So y equals 2/3 x minus 1. So again, just because my y-intercept is nicer with the blue equation, I'm going to start with that. So I'm going to go down to negative 1, and up 2 over 3, or down 2, left 3. And we'll connect, and we'll see if that's enough points to see our intersection. So to go back to the red one, up at 2.5, and down 1, right 2. Down 1, right 2. And I can see my intersection is at 3, 1. Okay, again, a couple things to remember. If you get your equations in slope-intercept form and they're the same equation, it's the same line, so if you graph them, you'd be on top of each other, that's infinitely many solutions. They're all real numbers. Then if you get ready to graph your lines and they're parallel, or they have the same slope at different intersections, that means they're parallel, and that they'll never intersect, so it's no solution.